Welcome to Algebra 1. The learning goal for this episode is to learn how to graph quadratics in the form y equals ax squared plus bx plus c. Previously, we learned the effects that a and c have on the graph of our parent function, y equals x squared, when we graph y equals ax squared plus c. A affects the width and the direction of the parabola, and c shifts it up or down vertically. Now we'll learn what to do when b is not equal to 0, so we do have a middle term, bx. In that case, our axis of symmetry moves from x equals 0 to x equals the opposite of b over 2a. The x-coordinate of our vertex changes from 0 to the opposite of b over 2a. And our graph will always have a y-intercept of 0, c. Here's a diagram illustrating the y-intercept at 0, c, the vertex at the opposite of b over 2a, and the line of symmetry at the line x equals the opposite of b over 2a. So let's look at this example, y equals x squared plus 6x plus 2. In this case, a equals 1, b equals 6, and c equals 2. So the opposite of b over 2a will be equal to negative 3. Since the opposite of b will be negative 6, then we divide by 2a, which is 2. So negative 6 divided by 2 is going to give us negative 3. Which means before we even start graphing, we already know that it's going to open up, have a regular width, have a y-intercept of 0, 2, an axis of symmetry of x equals negative 3, and the vertex will be at negative 3, negative 7. We know the vertex has an x-coordinate of negative 3, then we fill that in for x, and we get a y value of negative 7. So we start our table of values with the 2 points we already know. We know our y-intercept is 0, 2, and our vertex is negative 3, negative 7. Because my parabola is symmetric about the vertex, I can immediately put another point on the opposite side of the line of symmetry from 0, 2. Because 0, 2 is 3 units away from my vertex at negative 3, negative 7, I can immediately go 3 units the other way to x equals negative 6, and know I have a point that's negative 6, 2. Because there are 3 units between my vertex and my y-intercept, I decided to pick an x value in between my vertex and my y-intercept for my next point. So I picked x equals negative 1. Note that you can pick anything you want, but to keep my graph relatively compact, I'm going to pick values close to my vertex. When I substitute x equals negative 1 into my equation, I get y equals negative 3, which gives me the ordered pair negative 1, negative 3. Because of symmetry, I also know that I'll have another point, negative 5, negative 3, since that's 2 units on the other side of my vertex. So my graph looks like this. Let's look at another example. Y equals negative 4x squared plus 4x plus 8. My value of a equals negative 4, b equals positive 4, and c equals 8. Therefore, the opposite of b over 2a is going to be 1/2. So with those numbers, I know that this is going to open down, is narrow, has a y-intercept of 0, 8, an axis of symmetry of x equals 1/2, and my vertex is going to be at 1/2, 9. Again, I calculated the 9 by filling in 1/2 for x. So I start my table of values with the 2 points I already know, my y-intercept of 0, 8, and my vertex of 1/2, 9. We immediately know that we have another point at 1, 8 due to symmetry. Since 0, 8 was 1/2 unit away from our vertex, we know we have a point 1/2 unit the other way. I now pick another point, x equals negative 1, and calculate the point negative 1, 0. Due to symmetry, I know I'll also have a point at 2, 0. Now I can graph it fairly easily. Here's what my finished graph looks like. Now for our guided practice section. We're going to work through some problems together. You do not need to write down these problems, just step through them with me. At each step, I'm going to prompt you the question you should be asking yourself, then I'll pause for about 5 seconds for you to think about it and answer it for yourself. Then I'll show you. So for this problem, our first question is, what are we trying to do here? What we're trying to do is graph this quadratic equation. How do we do that? First, we identify our values of a, b, and c and calculate what the opposite of b over 2a would be. Now what? Now we can predict that our graph is going to open up, be narrow, have a y-intercept of 0, negative 3, an axis of symmetry at x equals negative 1, and a vertex of negative 1, negative 8. What's next? Next, we start our table of values with the 2 points we already know, the y-intercept and our vertex. Now what? Now we know a third point due to symmetry, the point that's opposite and symmetric to our y-intercept. What's next? Now we pick another point that's reasonably close to our vertex. I picked 1, 12. Due to symmetry, I also know that gives us negative 3, 12. Now what? Now we graph it, making sure all of our points are represented and then it matches our prediction. It does, so we're in good shape. Let's try another one. What do we do first? We identify A, B, and C and calculate the opposite of B over 2A. Now what? Now we know that our parabola will open down, be wide, have a y-intercept at 0, 1, and an axis of symmetry at x equals negative 2, and a vertex at negative 2, 2. What's our next step? We make our table of values starting with the 2 points we already know, the y-intercept and the vertex. Now what? Now we know a third point, negative 4, 1, due to symmetry. What's next? Now we pick another point close to our vertex. I picked x equals 2. When I fill in 2 for x, I get negative 2 for y, so my point is 2, negative 2. Due to symmetry, that also gives me negative 6, negative 2. Now what? Now we graph it and make sure it matches our prediction. It does, so we're good. Now for the self-check section. In this section, you're going to physically pause the video as you work out the problem on paper in your notebook. Then you'll press play to check to see how you did. You'll have 5 seconds to pause the video after I stop speaking, before I show you the solution. Please pause the video and work out the problem, then press play to check. Here is the solution. Please compare this to your work. Pause the video here if you need more time to compare, then press play again to move to the next problem. Same thing on this problem. Pause the video, write down this problem, and work it out in your notebook. Then press play to check. Please pause the video now. Here's the solution. Again, pause the video if you need more time to compare this to your work. In closing, let's review our learning goal. We wanted to learn how to graph a quadratic function in the form y equals ax² plus bx plus c. We did that by learning that our axis of symmetry moves to the line x equals opposite of b over 2a, that the x-coordinate of our vertex is the opposite of b over 2a, that our graph will always have a y-intercept of 0, c, and that we can use a table of values and symmetry to find additional points quickly and easily.